Hey guys, so welcome to the last video of notes that we have for the year. Woo woo. 11.3b is talking about reference angles. This is our last lesson for the trig. I do want to preface something though. There are some concepts in trig that we didn't get to. We were kind of running low on time and I didn't want to try to jam all this information at the very end and make your last week annoying for you. So hopefully just having one lesson and that's all you got to do this week, pretty manageable, because I'm sure there's other stuff you got to get in. So 11.3b is talking about reference angles. What we're going to be doing with reference angle is we are going to use these reference angles to create special right triangles that will allow us to find the values without using a calculator. So our example 1 here, the reference angle of theta is the acute angle of theta prime formed by the terminal side of theta and the x-axis. Now it's a very math way of saying that it's going to be an acute angle that has to touch the x-axis. And remember, an acute angle is any angle between 0 and 90 degrees. It has to be smaller than 90, but bigger than 0, basically. So to find the reference angle theta prime for each angle theta. So here we're given 140. So what we're going to do is we're going to draw a 140 degree angle, which would be about right there. So here's 140 degrees. But we don't care about that. We need to know, well, how far is it to get to the x-axis? So if I were to draw a line down here, what is this value right here is what you got to ask yourself. We already went 140 degrees, and we know that if we want to get all the way down to touch the x-axis right here, we would have to go an additional 40 degrees. Because 40 plus 140 gets us to 180, and we know that halfway across is 180. So the reference angle here is 40 degrees. That would be our answer. Next, theta equals negative 3 pi over 4. So here, whenever you see something in radians, we want to convert that into degrees. So hopefully we got this down. 180 over pi times that. Our pi's are going to go away. And then negative 3 times 180 is going to be negative 540 over 4. And then negative 540 divided by 4 is negative 135. So if we were to draw a negative 135, that would end about right here, and it goes this direction. Negative 135. So now we need to think, well, what's the closest way to get to the x-axis? And it would be to continue going clockwise. And we need to figure out, well, what's that extra distance I need to go in order to reach that? And it would actually be another 45 degrees that we got to go, because that would get us to the negative 180. So the reference angle here would be 45 degrees, because that's how much more we need to go to touch the x-axis. And 45 plus 135 is 180. So the reference angle here is 45 degrees. And again, our final answer has to be between 0 and 90. And it's a positive answer. The reason we would have negatives, that would come into play later on with what we're doing in the second half of this lesson, which I'll show you. Theta equals negative 130. So negative 130, we would have to go about right here, because it's greater than 90, so we know it would go past this point here. So negative 130. So now you need to think, well, how am I going to get to negative 180? How much more do I need to go? And that would be 50 degrees more. 50 plus 130 is 180, but it's still a positive answer because reference angles are always positive. 5 pi over 6. So we're going to multiply that by 180 over pi, convert it back into degrees. Pi's go away. 5 times 180 is 900. Divided by 6 is going to give us 150 degrees. So 150 falls in quadrant 2. One's a little bit further than 140. So we got to 150. Ask yourself, how much more do I need to get to that 180 here? It's not always 180. You're going to see in the later examples, sometimes it's actually how far do we need to get back to 360. It's just whichever is the closest point on the x-axis. In this case, 180 is the closest point. So we would have to go an additional 30 degrees. And 30 plus 150 adds up to 180. So 30 is the reference angle. Okay, so evaluate cosine of negative 150, give an exact answer. Now you're going to see why we need those reference angles. So cosine of negative 150, negative 150 is going to end up about right there. So here's our negative 150. And then how much further do we need to go? And if you haven't noticed this, what I always do when I draw the straight down line is I form a triangle. So this would have to go an additional 30 degrees. And 30 is a really nice number because it's part of our special right triangle. So I'm just going to take this triangle image and I'm going to place it off to the side here. So we know that this angle here was 30 degrees. This has got to be a right angle since I went straight up and down. And then that leaves this to be 60, and we end up with that 30, 60, 90 situation. If you remember earlier when we were talking about the special right triangles and we don't have given values, across from the 30 we assume it's a 1. And then we know the relationship between the short side and the hypotenuse is it's double, so 1 times 2 would give us 2, and then the long leg is times the square root of 3. So we have 1, 2, and square root of 3. We are looking for cosine. So cosine of our 30 degrees is the reference angle. So cosine of 30 degrees, cosine is adjacent over hypotenuse. So this is our adjacent right here, that's square root of 3, and this is the hypotenuse. So it's square root of 3 over 2. Now, if we were looking for the cosine of 30, that'd be our answer right there, we're done. But we are looking for the cosine of negative 150 using the reference angle of 30. The problem is, if you remember in our last lesson, A, S, T, C. All students take calc. We are in the T quadrant. Cosine is not positive in the T quadrant. Therefore, the cosine of negative 150 is minus the square root of 3 over 2. If we were talking about tangent of 150 or cotangent of 150, our answer would be positive. But here the answer is negative because we're in the T quadrant, quadrant 3. Next it says evaluate sine of 120 degrees, give an exact answer. So sine of 120, this is a positive angle. 120 is going to go up kind of like that. I'm going to make a triangle. So I've already gone 120 degrees, but to touch back to the x-axis, how much more do I need to go? It would be 60 degrees. 120 plus 60 gets us to that 180. Okay, which means this angle up top here has got to be 30, and this is our right angle. Every single time that you're giving an exact answer for these problems, it's because you should be able to create a special right triangle. So the reference angles are always going to be 30, 60, or 45, some fashion like that. So if I draw my triangle off to the side here, 30's up here, 60's up here, right angle. Across from the 30, just like I said, is 1. Across from the hypotenuse, or the hypotenuse itself, is 2, and then 60 is square root of 3. We're using those values a lot. Okay, so we are looking for sine of this angle right here, 60 degrees. Sine is opposite, over hypotenuse. So if we were looking for the sine of 60 degrees, it would be square root of 3 over 2. We are looking for the sine of 120 degrees. So we need to think about which quadrant are we in? A, S, T, C. We are actually in the S quadrant, which is great because the S quadrant is where sine and its reciprocal cosecant are positive. Since we're in the sine quadrant, our final answer is also going to be positive. So here's a case where both the reference angle and the exact angle that we're talking about are both positive. Evaluate cotangent of 4 pi over 3, give an exact answer. Cotangent is one of those reciprocal ones, so we do need to be careful, and we'll talk about that after here. But 4 pi over 3 is, we don't know what that is in degrees, so let's go ahead and convert that. 180 over pi. Pi's go away. 4 times 180 is going to give us 720. And then when we divide by 3, we get 240 degrees. So 240 is going to go down here. So this is 240. Okay, so now the reference angle here is a little bit different. Does it make sense to try to make a triangle that goes this way to touch the x-axis? No, because it doesn't form a triangle. The most logical way to make a triangle would be to extend this part right here to the x-axis. So at this time, we're kind of going backwards. How far backwards do we need to go to get from this 240 back to 180? And if you were to subtract those, the answer is 60, which makes sense because that's part of a 30, 60, 90 triangle, like we would expect. So I'm just going to bring this triangle out again. So this angle was 60. This is our 90, which leaves this to be 30. So across from the 30 is our smallest value, 1. Across from the 90 is 2, and across from the 60 is the square root of 3. We are looking for cotangent of 60 degrees. That's our reference angle. Remember, cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So here is our angle 60, that's the reference. So the adjacent would be 1, and then the opposite would be square root of 3. So 1 over the square root of 3, but that doesn't fly because we have a radical on the bottom. So let's actually multiply square root of 3 on the top and the bottom. So the cotangent of 60 equals the square root of 3 on top, and then square root of 3 times square root of 3 gives us 3. Now we want to find the cotangent of 240 though. So let's think about, is this going to be a positive or negative square root of 3 over 3? Since we are in AST, we are in the T quadrant because our angle falls there. T is positive for tangent and cotangent. So our final answer would be positive. All right, evaluate cosine of 3 pi over 4, and then evaluate tangent of pi over 2. So 3 pi over 4. Multiply that by 180 over pi. Always want to convert these back to degrees so we know where they're going to fall. 3 times 180 is going to give us 540. 540 divided by 4 is 135. Check my notes here, make sure I did that right. Okay, 135 is right there. So, so the reference angle here, finally we have something other than the 30 or the 60. This is going to be 45 because that's what it would take to get to 180. So now we have the other special right triangle, which is the 45, 45, 90. So I'm going to draw that down here really quick. So 45, 45. Now, the 45s are the same value. These legs are congruent. So we're just going to say that they're each a value of 1 and 1. And then the hypotenuse is a little bit bigger. It's square root of 2 times bigger. So those are the values we're going to use. We're trying to find cosine of this angle down here, 45. Actually, it wouldn't matter. But cosine is adjacent over hypotenuse. So the adjacent is 1. And the hypotenuse is square root of 2. So the cosine of the reference angle 45 would be 1 over the square root of 2. Can't have the square root of 2 on the bottom, so we multiply by the square root of 2. And you get square root of 2 over those radicals cancel on the bottom, and we get 2. Okay, so cosine of 45. But we are in the S quadrant, ASTC. Don't forget about that. S, only sine and cosecant are positive, which means our answer here for cosine of 135 is actually going to be negative square root of 2 over 2. And just like in that last lesson I talked about, everything in the quadrant 1, A is positive. If you think back to when I talked about the quadrantals, cosine is always the x value. So the reason that everything in quadrant 2 for cosine is negative is because if you think about the x values here, these are all negative values. But the y values in quadrant 2 are positive because they're going up. And y goes with sine. So that's why sine's positive. Okay, if that doesn't make too much sense, don't panic. For those of you taking trig next year, I'm sure you'll get a recap of that. But just so you know. All right, last one. Evaluate tangent of pi over 2, give an exact answer. So conversion, pi over 2 times 180 over pi. Sorry if I go faster these. Pi's are going to go away, 180 over 2. We get 90. So 90, that's our favorite angle here. That is going to get us on one of the quadrantals. If you ever fall on a quadrantal, think about what would the coordinates points be if you were to extend just one unit up, down, left, or right. In this case, we're going up 1 unit from 0, 0. So it's 0, 1. So tangent of pi over 2. So this is our x and y coordinates. A little recap from last week. Sine equals y, cosine equals x, and tangent equals y over x, or sine over cosine. So in this case, we're trying to find tangent of 90. We don't need to use a reference angle for this one since it's a quadrantal. So this is just a special case. So tangent would be y over x. So y value is 1 over 0. Can you divide by 0? The answer is no. So it's undefined. Don't have to worry about any positives or negatives with that one. Okay, so remember, if it falls on one of the quadrantals, one of these points here, the extensions of the x and y axis, then it's either going to be 1, 0, 0, 1, negative 1, 0, or 0, negative 1. And then you just think about y, x, and y over x for tangent. Okay, all right, so what you guys are missing out on, since we didn't have as much time and I didn't want to overload you, graphing sine, graphing cosine, I know this looks kind of scary, and then translations and reflections of the trig graphs, so the sine and the cosine. These are concepts you will learn if you take trig next year, which I highly recommend for a lot of you. If you do want to learn these concepts in advance and you have some extra time this week and you want to meet with me, I will gladly go over them with you. I can link you some videos, or if you don't want to worry about them, don't worry about them. I'm not going to force you to. But please let me know if you have any questions on these lessons or any of the previous lessons. This is our last one. I'll be sending out probably a goodbye video since unfortunately I won't get to say goodbye in person. But I wish you guys all the best. Please let me know if there's anything I can do for you.